Pressure is created when there is a resistance to flow. In a hydraulic system, the main resistance in the system usually comes from the load on the actuator. However, resistance to flow is also present in all conveyors, such as pipe and hoses, as well as components, fittings, and such. In the given example, the rise in the system pressure is due to the resistance provided by the load on the piston. Observe that the pressure in the gauge is 0 at the start. As the pump begins to push oil, there is an immediate resistance to flow created by the load. This results in an immediate increase in the system pressure equal to the total resistance of the load and other circuit components as indicated on the pressure gauge. The load cannot move at all until pressure reaches a value sufficient to create a force equal to the resistance of the load. This example depicts the development of pressure in a system due to a restriction in piping. A relief valve set at 1000 psi is connected to the pump outlet. Using a manually adjusted faucet, the flow is regulated by alternatively increasing and decreasing the size of the orifice. When the valve is fully open, the pump delivery flows out unrestricted, showing that there is very low pressure in the system. As the faucet is closed to an intermediate position, the resistance to flow increases. With the increased resistance to flow, the system pressure starts to rise. This is shown by the pressure gauge. The faucet is closed still further and the system pressure rises. It reaches 1000 psi. The relief valve opens and part of the fluid flows out through it. This prevents the system pressure from rising any further, and the system pressure is maintained at 1000 psi. Fluids always take the path of least resistance. When parallel paths of different resistance are present in a system, the pressure buildup in the system is just enough to overcome the path with the least resistance and push the fluid through it. Consider 3 possible flow paths through valves A, B, C. For these paths, let's see how oil flows through the valves set at different pressures. In this system, check valves A, B, and C are set at pressures of 100, 200, and 300 psi, respectively. The pump pushes oil into the system. The pressure gauge registers an increase in pressure, and the system pressure begins to rise. Now the pressure is around 100 psi, and valve A opens and the oil flows through. If valve A gets blocked, the pressure will rise to 200 psi, and oil will flow out through the second path, B, which is now the path of least resistance. When resistances in a hydraulic system are arranged in series, the separate pressure drops or resistances are additive. Here, the valves used in the previous example are connected in series. Fluid begins to flow through the system. The pressure gauges before each valve show the pressure reading to be equal to the resistance of that valve plus the back pressure from valves downstream. Hence, the pressure required to open valve C is 600 psi, which is the sum of the resistances for valves C, B, and A. The pressure reading in the gauge placed after valve A is theoretically 0, as there is no resistance downstream.